Hi guys, welcome back. Today there's no new information. We're just going to go over everything that's going to be on your quiz. And I'll do this in a two-part video so you don't have to sit all at one time for it, okay? First, let's do what we did yesterday regarding motion of a particle along a line. Okay, most important, you need to know that if position is given, then velocity is the first derivative and acceleration is the second derivative. Okay? Also, for position, there is no standard notation like there is for velocity and acceleration. And all the problems I've given you have actually called position s of t, but it really could be x of t if it's position along the x-axis. If it was position on the y-axis, sometimes they use y of t. So there's no standard notation for position, okay? But velocity, first derivative, you can just write v of t. Acceleration, second derivative, and you can write a of t. And again, speed is the absolute value of velocity. So what is the difference between velocity and speed? Velocity gives direction. Positive velocity means you're going to the right. Negative means you're going to the left. Or if the scenario is going forward or backward, positive velocity means forward, a negative velocity means backwards. Same thing with up and down. Okay, all the stuff you were supposed to memorize. Treat this next part right here like a quiz. Look at your notes, study it, and make sure you can justify all of these very quickly without even thinking. All of this will be all year, okay? So you'll need to know this cold, on the fly, and very quick. So first of all, remember, for everything regarding motion, okay, all of those justifications include velocity. Don't use the word it is positive, it is negative. That's no good. Be specific. All of them have the word velocity. So how do you justify particle moving to the left? Velocity is negative. How do you justify particle moving to the right? Velocity positive. Since those include positives and negatives, that would be a sign chart if you're given the equation. Particle stopped, not moving, velocity is 0. Particle changing directions. Went from left to right or right to left, so the velocity changes sign. That also implies that it is 0, but you don't have to state that. Speed in general is the absolute value of velocity. And if you're looking at a graph, that can be enough information for you to visualize the answer. But speeding up and slowing down, again, on a graph, you can figure that out. But the formal justification and what you need if you have an equation instead of a graph, speeding up is when velocity and acceleration have the same sign. Slowing down, velocity and acceleration have different signs. Okay, notice velocity is in all of them. All of these require a sign chart except for when the particle is stopped because there is no sign there, no sign change. Okay, so those are all the things you have to know cold. Now let's just sort of do an easy visual review. Okay, if this is the velocity that's given in this graph, then describe the motion of the particle on the x-axis, if this is velocity. So the first one, moving to the right, would be velocity positive. Well, if this is the velocity graph, then velocity is positive when it is above 0, above the x-axis. So velocity positive would be all of this and this, everything above 0. That's velocity positive. So how do you write that answer? We'd say the velocity is positive from 0 to 2 and from 6 to infinity. Union 6 to infinity. Okay, that's velocity positive and moving to the right. So everything in blue is moving to the right. Moving to the left would be when velocity is negative. And again, this is velocity, so it's negative when it's below 0. This is moving to the left when velocity is negative. Okay, so moving to the left would be from 2 to 6. Okay, before you move on, study that. Everything above 0 is velocity positive, moving right. Everything below 0 is velocity negative, moving left. Okay, well, if that's moving left and moving right, I'm going to skip stopped. Well, we can do stopped. Stop would be velocity of 0. So stopped would be at the beginning of this problem right here, here, and here. So the particle is stopped at t of 0, which is actually when it starts this problem, and 2 and 6. Now, changing directions, you have to actually change signs. So changing directions would be when it goes from positive to negative or negative to positive. And hopefully you can see that that only happens here and here, 2 and 6. Okay, study that. That's velocity positive means going to the right, velocity negative going to the left. Now let's do speeding up. Okay, speeding up and slowing down. Again, speed is the absolute value of velocity. So at this spot right here, that would be a velocity of 5, okay, and also a speed of 5. Over here, however, that would be a velocity of negative 17 and a speed of just 17, because speed is the absolute value of velocity. What does the negative 17 represent for velocity? If you say the velocity is negative 17, the negative represents moving left at 17, whatever the units are, feet per second, whatever, okay? So speeding up is when you're going away from 0. So speeding up would be, if this is a speed of 0 and this is a speed of 5, we're speeding up right here. But this right here is also speeding up because you're going away from 0. This is a speed of 0. This is a speed of 17. We sped up if we went from a speed of 0 to a speed of 17. Also speeding up would be right here. A speed of 0 to a speed of 19 or more, okay? So speeding up is when you're going away from 0. These spots right here in red, those are speeding up. Okay, so going away from 0. Here's 0, that's a speed of 5. Here's 0, this is a speed of, let me try that again. This is 0, this is a speed of 17. So from 0 to 17, speeding up. Okay, going away from 0, speeding up. Going away from 0, speeding up. Going away from 0, speeding up. So my answers for when is the particle speeding up? It's from 0 to 1. Also from 2 to whatever you think this is, maybe 4.5. And from 6 to infinity. Okay, so now obviously slowing down is going to be the other stuff. So slowing down would be here because you're going towards 0. You're going from a speed of 5 to a speed of 0. That's slowing down. But this is also slowing down because you're going from a speed of 17 to a speed of 0. So slowing down is the two blue sections. Slowing down would be from 1 to 2 and from whatever we said that was, which was an estimate, 4.5 to 6. Okay, now let's focus on that speeding up and slowing down again because that's the most confusing part. So in red, when you're going away from 0, away from 0, away from 0, that's speeding up. Slowing down, going towards 0, here and here. Okay, now if you understood that visually, now let's talk about speeding up and slowing down again using the formal justification. So we discussed that speeding up is in red and slowing down is in blue, but how is that according to the formal justification? Speeding up is velocity and acceleration have the same sign. Slowing down is velocity and acceleration have opposite signs. Well, let's look at that graphically. First, let's focus on velocity. Well, this graph is the velocity graph. The title of this is velocity. So velocity is positive when it's above 0. So let's go write down all of the velocity. The velocity is positive here, because that's above 0. Velocity is positive here, that's above 0. And velocity is positive here. All of those, that's all. Everything above 0 is velocity positive. Below 0 is velocity negative in these two regions. Okay, so that's the velocity, sign of my velocity. Now let's do that same thing for acceleration. What is the sign of my acceleration? Well, if this is a velocity graph and acceleration is the derivative of velocity, then acceleration would be the slope of this graph. Remember, derivative equals slope. So let's look at the sign of the acceleration, which is the same as the sign of the slope. So in this first region where it's red, that's a positive slope. So that's a positive acceleration. In the next region, this is a negative slope. This blue stuff here is a negative slope. So that's a negative acceleration. In the next red region, this slope is also negative, so that's a negative acceleration. And in the blue region, that's a positive slope, so a positive acceleration. And then the last red region, this is a positive slope, so it's a positive acceleration. Well, now let's look at all the signs. We said that everything in red represents speeding up. Well, notice in all of the red regions, signs are the same. Signs are the same. Signs are the same. In blue represents slowing down, and that's where all the signs are the opposite, okay? Slowing down, signs are opposite. Slowing down, signs are opposite. Again, when I give you the graph, you can think of slowing down as going towards 0, and you can think of speeding up as going away from 0, but this formal justification is what you need when you're not looking at the graph. Which brings me to the next problem. Okay, now let's do all of those same questions using no graph. Now, yes, if you wanted to graph it, you could, but not everything's going to be graphable. So we're going to try to do this without a graph, okay? So remember, all of our justifications, all of our motion things all have velocity in their justification. And this is not velocity, this is position. So the first thing we need to do is get a velocity equation. Okay, so velocity is the derivative of position. So let's just do the derivative real quick. Now, by the way, so far I've given all very, very easy derivatives. They're all power rules. So you might be jumping to some conclusions that aren't always going to be true, like on your sign charts. But I'm just trying to keep the math easy right now so you can focus on the concepts. The actual math will get trickier. Okay, so we need a velocity equation. We need the derivative. Negative 3t squared plus 40t minus 100. Okay, so if I want to describe the motion of the particle, then I'm going to want to do a velocity sign chart. So that's my goal, velocity sign chart. Well, in order to do a sign chart, I want to know where velocity is positive and negative and such. I guess I'll have to start by finding when velocity is 0. So we're going to find when velocity is 0 first, so set it equal to 0, and then factor. Now, if it's not factorable, we would do the quadratic formula, but these are all factorable. Now, anytime the first term is negative, you got to make sure you factor that out first. Don't divide by it, because we still need to use these factors to do our sign chart. If you divide by that negative, all your answers will be the opposite of correct, which, well, that would be wrong. So we're going to factor out the negative first of all. And then there doesn't appear to be anything else I can factor out. So I'll just factor out the negative for starters. Then factor what remains, factor that again. Keep that negative there though. Even though, because we have an equation right now, normally you could divide by -1 and get rid of the negative, we have to use the factored form of this velocity equation to do our sign chart. So we don't want to lose that negative. All right, so now ignore it. Factor to get a 3t squared, I'll do 3t times t. To get a 100, I have a few choices. So 20 times 5, 10 times 10, 25 times 4. I got to work with the inners and outers so I can get that -40. so let me try 20 and 5. Let me see what we got here. I tried 20 and 5. That didn't work. So next I'm trying 10 and 10. My inners give me 10t. My outers give me 30t. And yeah, I can get a negative 40 out of that. Make them both negative. So that's factored. Okay, then set each factor equal to 0. So we have this will equal 0 when t equals a positive 10/3. And you need to kind of in your mind think of that as 3 1/3 because we're going to put it on a number line. And then the next one, this will equal 0 when t equals 10. So put those values in order on your sign chart. We have 10/3 or 3 1/3, and we have 10. Okay, now we need to check the sign of velocity surrounding those points. This is when it's important to use the factored form of velocity. So I'm going to rename this as velocity again. That's what it really was. It was the same as this equation except that I factored it. And now I'm going to choose values in each of these 3 sections of my sign chart to plug into these factors. Okay? So in the first region, to the left of 10/3, I could use 0, I could use 1. And remember, during this part, you don't care what the actual answer is, you just care what is the sign of the answer. So if I plugged in 0, for example, this negative will always be there. That's not going to go away. This group, if I plugged in 0, that would also be a negative. And this group, if I plugged in 0, would also be a negative. And when you multiply 3 negatives, you get a negative. So this sign is negative. Okay, between 10/3 and 10, this section, well, if 10/3 is 3 1/3, I could plug in 4 or 5 or whatever I want. So I'm going to plug in a 4. So if I plug in a 4 for each group, again, this negative will never go away. We have that guy. Plugging in a 4 here, I get 12 minus 10, that's a positive. Plugging in a 4 here, I get a negative. And 2 negatives multiply to a positive. So in the middle, it's positive. Okay. Last group, to the right of 10, I guess I'll plug in an 11. What the heck? Plugging in an 11. Okay, when I plug in an 11, again, this negative is always there. Plugging in 11 here, I'd get 33 minus 10. That's a positive. Plugging in 11 here, that would be a positive. And 1 negative multiplies to a negative. Now, this is one of those things, by the way, that I was saying, because I used all polynomials that were easy to do the derivative of, you might assume that the signs always go back and forth like this, negative, positive, negative, but that's not actually true, okay? It's just that I'm trying to keep the problem simple. All right, so what does this mean? What does this mean on my velocity sign chart? What does that tell me? So what are all the things that we can get off of this sign chart? Well, first of all, always give your sign charts a title. Since this is velocity, when velocity is negative, that tells me particle moving left. When velocity is positive, that tells me particle moving right. So the particle moving to the left would be this piece and this piece, because that's where velocity is negative. So negative infinity to 10/3 and from 10 to infinity. Okay, but I intentionally just made a mistake right there. If this 10/3 represents time, this is time, you can't have a negative time. So this negative infinity doesn't really make sense. In reality, 0 is the beginning of that problem. Okay, so the negative infinity is wrong. Okay, but I just wanted to point that out. Time starts at 0. I can't go backwards in time. So it's actually going to be from 0 to 10/3. But then the other glitch is 0 was smack dab in the middle of this shaded region. So we include it there. What does that mean? Any of these spots here that we found, that's where velocity was 0. That means the velocity was neither positive or negative. So those are always going to have parentheses, because that's not where they were moving left. That's where it was 0, okay? So usually it's parentheses. You're going to use parentheses most of the time, unless a number is smack dab in the middle of a shaded region like it was right there. So moving left is the velocity negative in red. Moving right, velocity positive in blue. So that would be from 10/3 to 10. Stopped, velocity 0. Those are the initial points we found here and here. So stopped would be at 10/3 and 10. And changing directions, velocity has to change sign. So that happens to be the same answer as being stopped here and here, but that didn't have to be true if the signs didn't change. So again, 10/3 and 10, same answer for that one. Okay, by the way, go back to this velocity graph and notice that it's a negative parabola. So graphically, those same answers, the x-intercepts would be at 10/3 and at 10, and it's a negative parabola. I don't know exactly what it looks like, but using what we did on the last one, moving left is when velocity is negative. That would be here and here. Same answers. Moving right, velocity positive. That would be above 0, and that's that. So it makes sense. It's the same thing graphically and algebraically. Okay? So velocity sign chart tells us left, right, and changing directions or turning around. Okay, now let's talk about speed. Okay, so now let's talk about the speed of the particle. Remember, speed has to do with velocity and acceleration. So I have to first get my acceleration formula. Acceleration is the derivative of velocity. So this would be negative 6t plus 40. And I'm going to do an acceleration sign chart. And I want to line it up right underneath my velocity sign chart, okay? Because we have to compare the sign of velocity and acceleration in each region. All right, set that equal to 0, and we'll solve that. T would equal negative 40 over negative 6. So that would be positive 20/3. And yes, you got to know where that is. So that would be, make that a mixed number if you want. Divide, and you'd get 6 2/3. So I need to know where it is so that I can put it in the right region, comparing it to my velocity graph. So it would be 6 2/3. So that's between 10/3 and 10 somewhere. Okay. So now find the sign of my acceleration. Okay, we're going to plug it in here. There's just one factor. If I plug in a number to the left of 20/3, I could plug in 0 or 1, and I'll get the acceleration as positive there. If I plug in a number to the right of 20/3, I could plug in a 10, I could plug in 100, I could plug in 1,000, and you'll get acceleration as negative there. Now I have to put it all together to find speed. Are we speeding up or slowing down? So I'm going to make another sign chart just to organize my work a little bit better. And on this sign chart, I need to now compare velocity and acceleration. So this is my speed sign chart. Okay, so I'm going to kind of line these up. I need to have the 0, it's right here. I need the 10/3. Basically got to get all those cutoff points. I have a 20/3 and I have a 10. Now compare the sign in each of those regions. Left of 0 doesn't exist in the world. Okay, between 0 and 10/3. Between 0 and 10/3, velocity is negative, but acceleration is positive. Opposite signs means negative, slowing down. Okay, between 10/3 and 20, in this region here, well, between 10/3 and 20/3, I could do 12/3, whatever, it doesn't even matter because I can just look at the sign. So in between 10/3 and 20/3, my velocity is positive and my acceleration is positive there. So that's positive. Between 20/3 and 10, velocity is positive, but acceleration is negative. And to the right of 10, I have negative, negative, positive. So what does this tell me? Okay, speeding up is when the signs were the same. That would be this. Slowing down is when the signs are different. That would be this and this. Okay, so speeding up, velocity and acceleration have the same sign from 10 thirds to 20 thirds, and from 10 to infinity. Slowing down, when velocity and acceleration have opposite signs, that's 0 to 10 thirds and 20 thirds to 10. Okay, hope that helped. Remember, for speeding up and slowing down, you need both velocity and acceleration, and you have to compare their signs. So that's the first half of the review. All the rest I'll do in a separate videos. Hope you guys are doing well. Bye.